My presentation is called Fix the Cracks or Rebuild the Foundations. Okay, so who am I? My name is Gareth Hurley. I have about 15 years experience as a software developer. So as a software developer, how did I get my interest in testing and quality? Well, I was manager of a client support maintenance team, and we kept finding the same issues again and again, and it became quite demotivating and quite tedious. So this led me on a journey to try to find better ways to anticipate issues and improve the quality of the software. So I started by looking at various tools that could help developers with testing. But then I realized it's not just a question of tools, it's also a question of interactions and skills and other factors. So I won't talk about Murex. Robert has already done that very well. But two constraints we have is one, time to market is very important. It's a very competitive industry. And secondly, for a number of reasons, the quality of what we ship is also very important, not least regulatory requirements around the world. Okay, so my proposition is that development best practices are a key foundation of successful software projects. They impact everyone in the team in multiple ways, and they transform what is achievable in terms of quality, including testability. And I'm going to use a case study that I worked on in 2014 and 15 to illustrate this point. So this project looked at a traditionally painful area for many organizations, which is GUI testing. I'm sure we've all felt like that at one time or another. So we all know the issues. There are problems with random failures. There are timing issues, slowness. So even if your GUI testing suite is working well, it tends to be very slow. But because of the randomness that's involved and the timing issues, often test scripts involve sleeps and waits, which just make the situation worse. It often involves specialized tools, and therefore we require specialized team members to use those tools, leading to technical diversity. They can be brittle, so in an agile context where you have rapidly changing requirements and fast feedback, if you constantly have to rework your GUI tests, it can really be quite painful and have an impact on delivery times. And even worse, in many contexts and organizations, the graphical user interface may be the key entry point through which the entire end-to-end functional testing of the application is done. So your end-to-end acceptance tests and application tests are only as good as the GUI framework that you're working on. So we had observed in Murex in the Dublin office these problems on real-world projects. So we thought, well, could we do better? So I chose one particular project as a candidate to see what we could learn and what we could improve. So first of all, I have to say a lot had gone very right with this project. So it was an extremely ambitious project. Its main functional goals were achieved. It's now in production. It involved an enormous team. I think there were generally about 20 people working full-time, but maybe another 20 people heavily involved, and probably the same amount again. It was done in an agile way using Scrum with a cross-functional team. So the three amigos, for example, so you had business developers and QA all working together on this dedicated team. And highly complex requirements were delivered at the end of the project. However, not everything went so well, and this is what inspired us to look a bit deeper to see what we could change. So changing requirements, which of course we all know are the nature of all projects, but they became a real struggle, particularly in terms of testing. The automated GUI tests were delivered months late, well after a lot of elements of the project had otherwise been delivered. There had been an attempt by QA to open up their framework so that developers could use it to implement their own tests in a test-first philosophy, but it simply didn't work. The developers stopped writing them very soon, and that led to more bottlenecks on the QA side. So it became impossible in the definition of done to end a sprint with automation of the test scenarios. And even worse, with all of these issues, the GUI turned out to be the origin of many of the bugs caught in pre-release testing. My analysis showed that at some points it was about 50% of all of the bugs in the application. So the initial brief I had, and this was coming from a senior development manager who felt, yes, we could do something better, is given code designed in the right way, is it possible for functional and QA developers to collaborate on a testing API to drive functional testing without needing to render the GUI? So I'll explain what that means. So the idea is that this was the original test pyramid that we had. We were heavily dependent on manual tests, and these hard to write and slightly unreliable GUI tests beneath, and then a set of acceptance tests. So we wanted to invert the test pyramid, have less emphasis on manual GUI testing and the existing framework, increase the number of acceptance tests, open it up to a developer QA collaboration, and introduce unit tests, which were conspicuously absent originally. But we weren't just inverting the test pyramid, we wanted to see if we could invert the team roles and relationships. So could developers assist QA rather than the other way around? Could we change that relationship? So various issues were raised on the development side. What designs would support this type of collaborative model? What would be the cost of retrofitting it to legacy code? Would behavioral and test-driven development be a help or a hindrance with this model? On the QA side, in terms of test automation, so could we get rid of these random failures that we were observing? Functionally, what would be the impact on test coverage? So would we lose coverage? And would that matter if we were delivering more coverage faster? How would the collaboration work? Because now QA, we're going to be depending on developers to provide them with tools, which was an inversion of what we had before. And what would be the usability of the test API? And of course, a big question with all such projects, what would be the costs versus benefit? So it looked very easy at the start from a technical point of view. The developers said, oh yeah, we have this really fancy design, our code is very well separated, so the idea is that you'll be able to insert a thin test layer just below the rendering layer. So we're going to strip off the rendering layer. You still have the core code, including the business logic of the client, of the GUI, and great, now QA and or developers can test from here. So we have a new test surface, we lose a lot of the randomness issues around rendering, and still we can cover most of our functional test scenarios. So let's just measure the cost benefit and see how the collaboration works. So from a testing point of view, as a developer I worked with QA, both the functional testers and QA automation, and we did manage to find an API together that gave them the expressiveness they needed. So what I mean by that is they had functional test scripts already. So they were able to encode those functional test scenarios using this new API while minimizing the brittleness that had been there before. I won't go into what I mean by minimizing brittleness, but we favored business rules over GUI logic. So we talked about business objects and interactions like saving the data, checking the data, rather than row 5, column 1, coordinate X, Y, pressing the blue button. We tried to eliminate that kind of logic from our implementation. It actually all went badly wrong when we looked at the well-designed code. In fact, it turned out to be impossible to strip away a thin rendering layer from the business logic of the user interface. So the original design, not only did it not support this type of collaboration, it was actually a barrier to this type of collaboration. So I tried some cosmetic fixes. There are well-known techniques in the industry. There are books on the subject where you gently refactor code, and one of the aims is to improve testability. I tried that. It simply didn't work. I was getting nowhere. I was going home some days with my head in my hands thinking, I never want to see this again. So we realized fairly soon that we had to revise the scope. So rather than just being a question of interaction, we needed to completely rebuild the foundations of the code. So how would we do that, and what would the impact be? So before we did that, we thought, well, let's see, what did we do already and what can we learn about it? So the idea is that testability problems, from a code point of view certainly, are the tip of the iceberg. They indicate other quality problems, some of which may not be apparent at implementation time, but may surface months, weeks, years later. It's basically what we call technical debt, tightly coupled code, maintenance issues, less developer autonomy. So what I mean by that is both developers depend on other team members to do their testing, like QA for example, but also it's harder to facilitate handover within the team, and slower feedback, which slows down development, slows down delivery, and makes time estimation harder. So the result of all of that in this project had been that the cost of testing had increased, the burden fell on testers, and what we meant by testers were QA. So development and testing and QA reverted to their traditional silos. They simply couldn't work together because they couldn't deliver the automated tests at the same rhythm. Change was harder to manage, and not just enhancements and fixes, but also handover and communication. I was coming in as a senior developer, and I really struggled to understand this code. So you can imagine over years as this code has to be maintained, what the cost of these issues would be. So one lesson from that is that developer tests and code design are tightly linked. I don't talk about TDD as test-driven development. I think of it as test-driven design. And the point of that is that early testing on the development side gives vital early feedback on all of these quality issues I just mentioned. So if you don't have the early testing, you don't have the early feedback, and it's very hard to retrofit later. There are also issues of culture and people's habits. So even though it was a cross-functional team, there was still the idea that, oh, we're developers, we don't do GUI testing, that's really hard. That's something that QA do, and we're not going to worry about it. So what we found then also is that this project was extremely complex already. So we're asking a lot of a team to develop the significant skills that are required to design an application in a testable way. The business logic of this project was extremely hard. It was a big project. A lot of participants were engaging in Agile for the first time. There was just too much going on. So how could we expect them to build testability into their software? So what I would suggest is that if you really believe in testability and you want your development best practices to support it, you must invest in advance in training, coder dojos, in mentors who've already worked in these areas in the team, and build communities of practice so that participants, be they developers, QA, etc., can have links together across the organization and learn from each other's experiences. So after much research and many dead ends, I started again. I identified a simpler design and a method as well. So it's not just the design, it's how you go about implementing it. So what I did is I focused on one tiny use case, a real business case, and then I iterated. So I started small. And what I found is, as I iterated on business use cases, I was able to hang some of the existing code off my new design skeleton. I could see that my new design was robust enough to answer the functional requirements. And if you really want to know, the design I chose is called Presenter First, Passive View, Model View Presenter. So you're like, well, what's that? But I'll explain what the key features of it are. So there are clear responsibilities in the code. It's divided into layers with clear boundaries between the rendering graphical layer on one side, the domain business logic on the other side, and in the end, in the middle is a layer which is the brain of the GUI called the presenter, which helps to translate between the two. Passive view says that the graphical layer should be as dumb as possible. It doesn't make any business decisions. When you press on a button, the button doesn't know anything about what is going to happen as a result. And also, another advantage is you can swap out different graphical views. You can go from a web interface to a desktop interface. You can have both at the same time. In terms of method, as I said, I implemented the user stories quickly in thin vertical slices. And the way to do this is using mocking, where you abstract parts of the problem and leave them for later. And you do that by establishing a boundary, having a test mock or a substitute, and then leaving the details until later. And what that does is it makes change much easier because you haven't committed early to all of the details. And that facilitates behavioural and test-driven design and continuous refinement. Another key point is that Presenter First emphasises using the business language directly in your code. And that has two implications. One is the developers are now learning about the domain and the language of the domain, and they're looking directly at the business cases. But it also means, in terms of handover and support, that in the future it's very easy to understand the code because it's directly encoding the language of the business domain. Like, my business objects are here to limit dot, save, and so on. You're using, almost your code should read like sentences. So really we have a definition of done where we have implemented the feature and automated the test rather than weeks or months later. And I think the greatest feedback I got from both the technical and functional side in QA was how soon can this technique be rolled out for all GUI developments. So some final lessons that maybe contributed to this project. So organisational factors are very important. So here we had a senior project sponsor, it was a senior developer, and he laid down the groundwork because we were changing roles and requiring new skills of developers and QA. So he laid the ground by speaking to them in advance. And there was already a QA development relationship thanks to the agile model that had been applied in the original project. So QA did not feel threatened, development did not feel threatened or surprised by these new relationships. They were used to forming new relationships. So that really helped. The participants were motivated. They'd seen what had worked before and what hadn't worked before, and they were very eager to try something new. And as I said, there was communication between all stakeholders at the start. QA really felt that their needs were being addressed, that developers were listening to them, whereas developers saw that they had a level of power and control over quality that they never realised before they could have in the GUI. So yes, I discovered there was a better way. There were costs, but the benefits exceeded the costs once the skills were in place. And the ongoing challenge we have in Murex, and I'm still working on, is to embed such skills across all teams and to roll them out. So, any questions?